We'll talk about a hard server and a soft server. This naming has been given by me just to have a right mental model. Okay. We'll keep it very short. What we want to understand is how the infrastructure works, right? You are the software developers, you are the software programmers, and you work on certain environments, right? So the closest environment what you know is you have laptop with you. Yeah, that's you call your laptop as what? Desktop. Yeah, typically in IT world, when you go, people refer to this as a workstation. Of course, it's a workstation because you're working on it. It's a station where you do your work. What do they call? They call it as workstation. And so you will get to see these words. You know, your IT team will be talking about this workstation. And then when you act, this is a workstation. That's a broader thing, right? It's a device. It's an hardware. It's a product which you are using to do your development or whatever role you have and what you perform is called a workstation. And the kind of work you do or the type of work you do or the actual work you do, that is called workspace. It's called workspace. You're creating a space for yourself where you do a work. It may happen so that this laptop is a shared laptop. Okay, I am working till 8 today. After 8, the next shift starts and somebody comes and uses the same laptop. So what happens is the workstation is same for the couple of shifts, but the workspace what they will work will be different workspace. They would have created their own space. Space is nothing but a folder. You're writing a Java program, it will all your code, it will end up into a certain folder, but they generally refer to this as a workspace. Okay. Generally what you do, you are given a laptop or you are given a workstation or you are given a desktop, right, to perform your work or duties. Typically, generally in IT industry, when you go, people give you this device. Unless you have this device, you can't do anything. Agree? So you will have a workstation, which will be we call it as a local workstation. Okay, it is called local workstation where you start your work, but the nature of the workspace depends. Some clients allow you to create the workspace on your local workstation itself. The folder what you create, the programming folder, the project what you create to do the work, either it will be local or it can be remote. When you say it is remote, it is not your machine. You will be connected to a certain LAN, and the workspace what you are connecting, you would be connecting to a remote desktop. It will be a server or a laptop which will be residing somewhere else, where it will be in the control of the client, and you'll be connecting to that machine and you will do your work. Okay, it is called remote desktop connection. Why do they do that? It's for the security reason. They don't want you to compromise on their data security. You're writing the code, you are using their data. They will have the fear that you may end up selling their customer data, and that will be used for under some abuse, and then it will lead to a whole data security problem. Okay, it's a remote desktop. These days, your workstation, you will have a local workstation, which is your local laptop or a desktop. You could even code it online these days, right? So Python gives you this, what is this called? They have notebook, right? Which notebook? For Jupyter notebook. Yeah. So that notebook, you can use it cloud based, right? You code online, and then it will also map a local drive, but mostly it will be coming online. Yeah. And then it will seem like it is a local, but it will be cloud. A cloud is also nothing but it's some other machine. Here it is a LAN. Here it is local. The connection, right? The network. Here it is local. Here you are using certain LAN. LAN, it's not even LAN, it's a VPN connection, right? It's a secured connection. Virtual connection, it will be a VPN connection, virtual connection, but it will be their own network. I mean, for the client or for the institution we are working, it will be their own private network. Yeah, but then the cloud becomes World Wide Web. The way you buy it, they can make it private or public. It's on the internet. This cloud becomes internet. Okay, three type of things, right? So this is how you work. Yeah, and then so now let us take this forward and try to understand. So this is something which is your local environment. We call it as a local environment or your development environment. You are doing the development there, your own development, right? Your development environment. You are given a task and you are doing the development on it. Now, you finish your development. There are three different teams which have modularized the program. Okay, there is one UI team, there is one middleware team, and there is one backend team. Okay, that is how your application is. UI, and now all of you are given a certain requirements. You all are working in parallel. At some stage, you all three, these are called components. They are different teams. You can call them as components, modules, or they are different teams. And all these teams at some stage need to integrate. Okay, that is called component integration testing. Okay, so you integrate all these three systems, three components are integrated, and somebody, there will be a testing team which will test whether they meet the requirements or not. Okay, and then when these three components are let us assume they belonged to a same domain. Okay, and there is one more team called reporting team which is outside, little outside. Okay, these three come under certain line of business and they do it, but then reporting is an application. This is also part of the overall solution. So then now they also need to get integrated. So from this will also get integrated. It's called system integration testing. Okay, these things are used as per their meaning, right? Some people don't even do CIT. We call it as CIT testing. This is called SIT testing. Okay, some people, they do SIT testing directly. They don't do this. Yeah? Some people, they will have such a setup. Okay, so you will do system integration testing, and there will be a testing team which will test this application. They will integrate all of them and they will test. Before CIT and SIT, you as a developer, you would have done unit testing. Remember these with the names. Unit, they called it as a unit. In the manufacturing industry and our hospital, if you go, they will say certain departments are called with the name as unit. You go to a cancer unit, you go to a X-ray unit, you go to a certain, billing unit. Unit is nothing but a department. Okay, so you are responsible for a certain component and you are responsible for that unit or a department. You own that department. So since you own that department, you will have to, your responsibility doesn't stop only on development. Your responsibility is also to test your unit. And there are so many ways to do the testing, which we will see it later. Automation testing, how do you test your application and all. So you do the system integration testing. After you do the system integration testing, inside the system integration testing or outside, it depends on the setup. But what happens is, people also do a regression testing. Okay, regression is the opposite word of progression. Progression means you're progressing forward, something is going forward. Regression is something is going backward. So you test what is already there. Some functionality was already there. Just because you build something, you should not mess up with the old functionality. That should still be intact, and on top of it you would have built your new feature. Just because you are adding a new feature, you're not supposed to mess up with the old feature, and that old feature also need to be tested just to ensure that developer has not messed up with that, right? That is called regression testing. Once every regression sometimes is a part of SIT itself. Okay, and once regression testing is done, it is then pushed to a stage called UAT, user acceptance testing. User is somebody, the customer, you call them as a client, you call them as a client, you call them as a user, you call them as a customer, you call them as a business, okay, or you call them as a sponsor. These are the terminologies which you use interchangeably. Sponsor, they are the ones who will be doing the user acceptance testing. They are going to accept what you have. Either they'll accept or they will reject. Okay, so they will test your application and then they will give the sign off. Sign off is a very important word in IT industry. They are going to sign it off. Okay, it's approved. We have validated, we are good, or we are rejecting it. They will give the permission. Once they give the permission, there happens a testing called OAT. It is called operational acceptance testing. Operational acceptance is, some people do it, some people don't do it. Okay, this also will have this is sometimes also called a performance testing. Okay, so operational testing, what they ensure there is your API, Google as an application, right? You search something and it responds back in fraction of a second. Just because one Google developer changed something, Google should not come down, or Google should not start responding for one request. It should not take 1 minute. They should maintain that operation as it is. If it was responding in fraction second, 0.001 millisecond, it should still be responding into 0.001 millisecond with your change. It should not degrade the performance. Hence it is also called performance testing and operational acceptance testing. By any chance you are writing a code, you are not supposed to degrade the performance. Your performance should be kept intact. There are tools to measure the performance. We will learn on them in coming days, how it is done and all. Okay, so once it is done, it is sent to production. It goes to the actual production. There will be a separate production support team which will be managing the production, and it is taken care by them. So there is an entire process. When you started the client, user, customer, sponsors, they gave you the requirements, you started developing it, and you pushed the code to the new environment. This is environment 1, right? This is your local environment. This is environment 2. This is environment 3. This is environment 4. This is environment 5. This is environment 6. What is this environment? We'll talk. Okay, so these are different environments, right? And what is that you do between environments? You push the code. Okay, you push the code. There is also another terminology which is called, you sometimes you call it as push the code, you call it as deploy the code, or you call it as promote the code. All mean the same. Okay, people use these interchangeably. Push the code, deploy the code, promote the code, or host the code. All mean same. Okay, so when each of these environments are what? Each of these environments, you started with a local desktop. Let us assume you're working on a local laptop. Okay, but then this is your environment 1. With this, you ended up pushing the code to environment 2. But this now environment 2 is a server. Okay. So this is what is the today's topic. This server is, I am naming it as hard server. Hard servers are the physical servers. There will be a data center somewhere, and that hard server will be residing there. So IBM, HP are very famous in giving the hard servers, but these are very big servers. These are not small laptops like us. These are very big servers. So this is a hard server. The client, the customer would be, if they are maintaining their own infrastructure, they will be having that hard server. On the hard server, there will be an operating system. Okay. The two famous operating systems are, generally in the industry, you will see either this operating system will be Unix based, Unix or Linux, or it will be Windows servers. Those are the operating systems. You are very familiar with the Windows operating system because that is commercially available and it's a home office laptops will have that. But then the Windows also gives the server, the enterprise server, operating systems. Okay. Linux or Windows is what you'll typically see. Mac is something which will come, but then these are the commercially very viable used. So this is a hard server, and then you have an operating system. Now for you to run your application, let us assume you at your stage, you know two important application. One is your DB engine is running, DB tables, you're able to do SQL, right? And so your Java application is running. Okay, you have written a program and you are executing it. You will not be executing your program on operating system directly. There is an in-between interface, right? And you will be hosting it into a Tomcat or whatever server. There are so many servers available, right? These are called application servers. You run your program on JDK, SDK, JRE, or generally you use application servers. There is a whole lot of difference between this server and this server. So many people, they get confused. We call them as application server. You are writing an application and that application is run on a certain application server. There are a whole lot of application servers. There are web servers available in the market. There are MQ server. There are DB server. For email, they use SMTP server. Okay. Likewise, there are different type of servers. So the soft server, what we are talking is this app server. You bought a very big box, but inside that big box, there is an operating system, and that operating system, you hosted this application server. Intentionally, we are calling it as a soft server because that is also an application. The server where your program is being run, what the Tomcat server or WebSphere application server or a JBoss servers, what you see, where you run your programs, I am just terming them as a soft server so that it is easy for you to remember. That soft server is an application server because that is also, it's not a physical device as such. It's an application. Inside that application, your application is run. Okay, so that is a soft server. So when you go into the industry, when you are working, you will see there is a team which will be managing this OS. We call them as Unix team or Linux team. We call them as a server team because the server itself may go down. And in an enterprise, it will not be your own application. The enterprise will have so many teams, right? So many teams will be using this as a shared server. These will be very big servers. This server team will partition the space, CPU, power, RAM, and all, and they will share it between different teams. Team in one application will be here, team 2, team 3, team 4. Many people can host their applications. Okay, so there will be a team called server team or Unix team who will be responsible for keeping the health of this box, the physical box. And then there will be a team for this app server. You as a programmer, you will not know, you will know how to set up, but if something goes internally wrong, you are not the expert. So there will be somebody who you will do those troubleshooting tips, you will shut down the server, you will make up the server. Yeah, but then beyond, if it goes beyond you, there will be an app server team where you could reach out to them and they will fix the issue. And then comes your application team. You are responsible for the application team where your SQL, your program is not running, it is having issue, it comes to here. And then this OS will have its own properties, right? Any machine for that matter. Okay, so you are most familiar with your laptop or a desktop at home. So it will have. Yeah, so if I do a task manager, Windows gives me a very beautiful interface, right? Just to see what is happening with my system. Okay, this is the task manager. What tasks are being done by Windows? It's a task manager, right? So here I go and I see how many processes are running here. Name of the processes, right? Process is one parameter. So at this given point, my system has consumed 23% of the CPU. CPU, memory, disk, network, GPU, yeah, and process. These are the most important parameters for any server. Yeah. So likewise, in Windows, I see it, I can take this and I can kill it. So it becomes an end task here. Likewise, what you could do is if you are managing it in Unix, you just saw it for Windows, but if somebody asks you to do it in the Unix, what you do, you connect that box. You connect it to this box, what we just saw right above. You connect it to this application server or this box itself. Okay, this box, we call it as box. This hard server, what is called, right? It is called box, Unix box. Okay, you connect it to this box. Okay, there are tools to connect to this box. So this is your local laptop. What you do is inside this, you will invoke an application. There are so many applications where you can connect to the box. It is called Putty. Yeah, you use FileZilla. There are many. Okay, but these are the famous ones. You use these applications to connect to the box, Unix box, that server, right? Yeah. And if you want to see the process, what is running here, you can, in the Windows, what you do, you can also go and see the processes. You can see the CPU, you can see the RAM, you can see the GPU, you can see the disk storage. The same things in Windows, they made a beautiful UI where it is easier, but in the Linux, Unix, there are interfaces there also, but then the techies, the software developers, the support person, the testers, they prefer to do the command based. This is all command shell based. You use the command to see the same thing what you are seeing it here. You will connect through Putty, FileZilla, yeah, and then not FileZilla but Putty in particular, it supports the command shell, and then you give the commands, and then Windows also has a command shell. You do not want to operate Windows using this user interface, but you want to do through the command. Windows also gives you a command shell. Okay, likewise Unix also, this platform, they also give you a shell prompt, we say. Okay, where you can go and write the commands and then do the necessary work. Okay, exactly. So what other things we do on Windows? We generally go to a directory. Yeah, we go to a directory, we search for a file, we create a file. Yeah, we put the content into the file, we delete the content into the file. The basic Windows operations, right? The basic computer, Other day we spoke, right? Why software is important. Mainly those capabilities of storage. And we go and search for that information. We would have stored it for the future use, and we are searching that. All those operations, what you are doing in Windows using your mouse with a double click, you could do the same thing on your Linux using the commands. Okay, so the same thing. Yeah. Okay, so now one closing point, we studied on the hard server and the soft server. We understood that now the current generation or the current era is everything has gone to cloud. So the difference is this is your local laptop, which is local to you, and you are connecting to a remote desktop or a remote server. Okay, so remote server is still on a VPN, some private network. You are connecting it using PuTTY. Okay. Yeah. But now these days, you can also connect to the cloud using the PuTTY. The only difference is this is a private network. Now this is on a public domain. You can do it with worldwide internet. Using internet, you can connect. Here, what you had to have a private network. You need to have a VPN. Only when you have a VPN, you can access this server. Now, if you are asked, let us assume you are sitting here and you are asked to connect it to an Infosys server, you cannot. Infosys server is a remote server unless you get into the Infosys network, virtual private network of theirs. If you're not talking, please go on mute, please. Thank you. Yeah. So you will have to be on their network, private network, for you to get access to that remote server. But on the cloud, this is a worldwide network. The biggies, there are so many cloud platforms, Amazon, Google, DigitalOcean, OpenShift. They are allowing, they are building the infrastructure these days. And you can go and access that information. You pay for that infrastructure and you get it. And why is that happening? Why is cloud becoming so famous? So last decade, it was this, we call it as a infrastructure as a service. Okay. Yeah. So everybody, all the big enterprises, right? Big banks, big enterprises, they used to maintain their own infrastructure. They used to buy big boxes. They will put a OS. There'll be a lot of applications and you will run your programs inside them. But they have to maintain this team. This team used to be called as an infrastructure team. And it is so, they have to shell out so much of money, resources for them to manage this. What cloud gives you is, I will not have a headache of managing this team, this infrastructure and all. It goes down and a lot of energy goes there. Rather, you build an application and you put it on my cloud. You take a headache of going down, security, all that. I will pay you and you put your application. So simple. I will not take the headache. Completely isolated. I will pay you, and Amazon or Google, you take care of all that headache of firewall, data theft, data security, everything. If it had to be done with my own local, it is so challenging, right? I need to build the team. I need to manage the resources. I need to maintain this infrastructure. This, when we are buying, when we would have bought these things, every year I have to pay the license fees for IBM, HP and all. This would be more cost for them, more nightmare, more effort, and then no discipline, because the people who are working on this, they will quit the company, all that. I will not take the headache. Rather, I will go with a standard who are experts on that. These guys are the expert and they guarantee the service that it will never ever go down. Your application will never ever go down. So that is where cloud is preferred. So, but how do you get to the cloud? You use the same PuTTY. It's still a remote for you. Either you connect to the remote server or the cloud, it is the same thing for you. Okay. One closing point. So whatever you see in the command shell, either you use in the command shell, and there are a lot of tools which are available, which have made a lot of UIs. Manage Engine is one example. Some people will come and say, no, I don't like to command. Command is so fearful. The black screen itself scares me, right? I don't want to write CD, PWD, LS and all. Who will remember? I don't want to take that pain. For such people like me, right? Who are the managers who doesn't like to do the coding. Those are the people who would prefer the user interfaces. Business, yeah. For them, lot of tools have been made where your user interfaces, where something what you see on Windows, you could see it on the UI itself. All your CPU, whatever we just saw, right? You could see on the UI. And the notifications will be sent. Suddenly your disk storage is 80% full, and email will come, or a message, mobile message will come that your server is full. Please immediately act on it. Such type of notification. There are tons and tons of tools which are made. All right. This is the hard server and soft server for you. It's a little too much of information for today, but what I insist is we'll share the recording. Please go through this. This is very, very important. All right. Okay. I'll stop the recording.